Hello ladies, gents, and everyones. It is Thursday, July 28th, and we're here to talk about this week's space and astronomy news. The Mars Sample Return Mission, which is a joint effort between NASA and ESA to return the samples that are being taken right now by Perseverance back to us here on Earth, has just completed NASA's System Requirements Review. This means that the design concept for what the mission will actually look like is getting refined based on the best available data. And there are some changes, the biggest being that the mission will now rely upon the Perseverance rover. Given the planned longevity for Perseverance and the time frame of the sample return mission, it was previously assumed that the rover would be immobile. But based on how well Perseverance is holding up, the plan is now that Percy will take its own samples to the sample retrieval lander. As a backup option, based on the overwhelming success of Ingenuity, there will actually be 2 sample recovery helicopters on the lander as well. Now, this new plan still needs to be approved by ESA, but hopefully this fall the mission will transition from this conceptual design phase into the preliminary design phase. We may be only about a decade away from having Mars samples here on Earth, which is so exciting. Last week, we talked about some new very high redshift galaxies uncovered by the JWST, including a candidate for the most distant galaxy ever seen. Well, in the past week, there have been a whole slew of new papers about distant galaxies posted to the arXiv preprint server. So this is a lot of new papers, and I'm not going to go into each of them, but what are the general scientific takeaways here? The first is just that there was a significant population of galaxies forming stars in the early universe. We're finding so many of them. There are several candidates vying for that title of most distant galaxy ever seen, including some out to a redshift of 20. Again, though, these are only candidates. GNZ11 still holds the title because this one is spectroscopically measured. These new galaxies only have photometric redshifts measured, which is much less accurate, so we can't say for sure that they are that far away yet. It turns out that these early galaxies are more defined and have more structure than scientists expected. There are up to 10 times as many disk-shaped distant galaxies as previously thought. And it's not just the super distant ones that are really interesting. There's actually a period of time called the cosmic noon that happened about 3 billion years after the Big Bang. And it's called that because this was the peak of star formation rate in the universe, so there's so much light being created. And in the infrared light seen by JWST, galaxies at cosmic noon are actually smaller than it seemed from Hubble observations, meaning we might have a lot more to learn about how galaxies evolve. It's been barely 2 weeks since JWST started releasing scientific data, and we already have this bounty of cool findings. It's going to be a great few decades. When objects get too close to the powerful gravity of a black hole, they get what's called spaghettified. They get torn apart and stretched out into these long strings thanks to the tidal force of the gravity. And this happens to stars too. So when stars pass close to a supermassive black hole, they undergo this tidal disruption and they accrete onto the black hole, which produces a lot of energy, and we see that as an outburst from the supermassive black hole that can be brighter than a supernova. But interestingly, astronomers have seen a few tantalizing cases of large outbursts of energy months after the disruption event. A so-called zombie black hole coming back to life. Well, now a new model predicts that these delayed outbursts are caused by changing density in the accretion disk around the black hole as the speed of the spaghetti winding around the black hole changes. Basically, during the initial event, the gas is dense enough to reabsorb emitted radio waves, but as the density decreases, those radio waves eventually can burst through. And these types of delayed outbursts could provide scientists a new window into investigating the behavior of black holes and learning more about these weird objects. We've long known that the sun has an 11-year activity cycle as it goes from a minimum activity, as measured by things like sunspots and solar flares, up to some maximum activity as the direction of the sun's magnetic field flips. But how high that maximum is and how low that minimum is varies from cycle to cycle. Given the effect that solar activity can have for us here on Earth, it would be really great if we could actually predict what a solar cycle would look like, but unfortunately it turns out that's actually really hard to do. The current solar cycle, which is cycle 25, started back in December of 2019, and at the time, a panel of international experts made a prediction about what they thought the solar cycle would look like. They ended up concluding it would look similar to solar cycle 24, which was actually a below-average cycle. But now, as we are shifting away from the minimum and starting to approach maximum, which will occur in about 2025-ish, the sun is actually more active and already exceeding those predictions. In fact, the data so far are more in line with a prediction from a different study that predicted that cycle 25 would rival some of the top cycles in history. Given our ever-increasing dependence on space-based technology and supporting ground-based infrastructure, facing such a high-activity cycle like this could be an unprecedented challenge. And lots more aurora. Lastly, we've been hearing a lot of threats from Russia ever since their invasion of Ukraine that began back in February that they are going to pull out of the International Space Station. Given the nature of the ISS, it would be really difficult to continue operations without the Russian partnership. Most recently, this has been in the news again this week, as on Tuesday, the newly appointed head of Roscosmos stated that Russia would withdraw from the ISS after 2024, which is when the current formal agreement ends. This announcement came as a surprise to NASA, who hadn't been informed of any such upcoming move. However, that announcement does seem to be being quickly walked back, as on Wednesday, another Russian official stated that Russia will stay on the ISS until their independent space station is operational, which is expected no earlier than 2028. So will Russia sign on to a new formal agreement beyond 2024 for the ISS? I don't know. Maybe they don't even know. However, if they want to continue their manned spaceflight program without interruption, they need the ISS. Well, that's all the news I have for you this week. Thank you so much for joining me. If you enjoyed this video, I hope you will consider liking it and subscribing to my channel. Thank you so much for watching, and I'll see you again next week. Bye!